Welcome to qnawire.
Hi, so in this case we're given a set of statements about transition state theory, and we need to say if the statement is true or false. So for the first one, we're told a transition state can never be lower in energy than the reactants from which it was formed. And this is false. There is no actual restriction in transition state theory for this to happen, and actually there are reactions that have a negative activation energy, which is not negative itself, but we refer to this type of reactions as barrierless reactions. And for those type of reactions, the rate of the reaction is given by the collision frequency and not by the height of the energy barrier that we need to overcome for that to happen. Now, next, for B, we are told that an endothermic reaction cannot have more than one intermediate, and this is also false. There is no limitation on how many intermediates we're going to have in a reaction. For example, you can look at any catalytic cycle in which the energy tends to go down, and you're going to have a lot of intermediates in between. So, for example, we can have reactions that look like this: one transition state, we arrive to one intermediary, another transition state, and we can arrive to another one. So, this is an example of an endothermic reaction, sorry, of an exothermic reaction that has two different intermediaries, and we can have exactly the same for an endothermic reaction with any amount of intermediaries that we want. So for B, this is going to be false. The same thing is going to be for C, which we look at the case for an exothermic reaction. So this barrier would be for C and this would be for B. All of them would be false. We can have more than one intermediate in each of the cases. For D, the rate determining step is the step with the largest difference in between energy and in between products and reactants. And this is going to be also false. Why is that? Because we can have reactions that have a very high energy barrier and a large difference of energy in between them. But this doesn't mean that it is going to be the rate limiting step of a reaction. We can have, for example, a reaction in which the energy difference in between reactants and products is very small, but the energy barrier is quite large. So this is going to be false because the rate limiting step is given by the step with the highest activation energy. And finally, for E, we're told that transition states exist for long periods of time but can be readily isolated. And this is not always true. This would be kind of partial because in general transition states are short-lived. There are of course some exceptions of transition states that go for a very long time. For example, in the clock reaction, where the reaction is so slow that you can actually isolate the transition state. But even though transition states are short-lived, there are experimental techniques in which you can isolate or at least detect them in some way. So even though you cannot, for example, grab a flask and say, oh, this has all 0.20 fraction of a transition state, well, what is going to come from here is that in general, transition states are short lived. So this would be false as well, since isolating them is very difficult, and I would say that it's easier to detect them. They can be detected, but isolated, hard to do, with probably some exceptions. And that would be all. Thank you very much.